Problem 21, we're taking a look at coordinate points and finding the distance between them. So I have a coordinate point at 3, -6, and another one at -2, 5. If I draw a line between the two, that's the length of the line that I would need to find. So this can be done easily with a slope triangle. So if I go from the top point, I will go down a distance of 11. Now technically that would be a -11. However, since we're dealing with length and not a slope, I don't need the negative. Then I would go to the right 5, and my slope triangle is a right triangle. The hypotenuse of that right triangle is going to be the distance of between the 2 points. So Pythagorean theorem will now allow me to solve for that length. So I would have 11 squared plus 5 squared equals the length I'm looking for, the hypotenuse, x squared. So simplifying the 11 squared and 25 squared, I get 121 plus 25, which when I combine those two, x squared is going to equal 146. So x is going to equal the square root of 146. And it also says that I can give the decimal approximations of those. So my decimal approximation for this will be approximately 12.083. Problem B, I'm going to do very similar to that. And I'm going to show one other thing as well with this problem. So if I have a coordinate point at 5, -8 and at -3, 1, again I'm going to draw the line between them. Now I could do this without even having a graph, because the distance that I'm going from that point down is the same as the distance between 1 and -8. That is a distance of 9 units. Whether it's positive or negative, again, does not matter, because I am looking at lengths. I'm also doing Pythagorean theorem and squaring it, so it would come out positive either way. My other side length there would be the distance between the 5 and the -3, which is 8. So now doing Pythagorean theorem here, I would have 8 squared plus 9 squared will equal my hypotenuse, x squared. Again, I'm going to square both of these numbers, and I'm going to combine them to get x squared to equal 145. So x will equal the square root of 145. My decimal approximation for that is about 12.042. Once again, looking at the next problem, I have my coordinate points at 0, 5 and 5, 0, and making my line between them. So once again, making my side length there, that one is 5 and that one there is also 5, giving me 5 squared plus 5 squared equals my hypotenuse, x squared. So 25 plus 25 equals x squared. X squared will equal 50, and x will equal the square root of 50, which is approximately 7.071. However, we can take another look at this one. Problem D wants us to look even further and simplify this in simplified square root form. A couple different ways we could look at this one. This triangle, if you remember back from geometry, is a right isosceles triangle. That was one of our special right triangles that had a ratio of x, x, and x square roots of 2. So if you remember that from geometry class, that means that the hypotenuse here would be 5 square roots of 2. And that would be in simplified square root form. If you did not recall that, then we could think back to our answer to problem C, which was square root of 50. And to simplify that, we need to find a perfect square that divides evenly into 50, and that one is going to be 25. So square root of 50 would be the same thing as the square root of 25 times the square root of 2. Square root of 25, being a perfect square, will now simplify down to 5 times the square root of 2. And there's the simplified radical form.